heaven and earth than are dreamt of in our philosophy.
There are more things in heaven and earth than are dreamt of in our philosophy.
Today I'm going to challenge you to do the impossible. Well, that's what I read in a psychology book when I was a nerdish teenager. The topic was coordination, and it mentioned a hand coordination that it said was impossible, or almost impossible. Now, I'd already mastered flaring my nostrils and raising each of my eyebrows separately. So, to distract me from worrying about my acne, I decided to give it a go. And, yeah, did it. So, am I a freak? Because I've never met anyone else who can do it. And that's going to be my challenge today. Can any of you also do the impossible? I don't want to be alone. Hello and welcome to Louis Sinclair Investigates, one of the mysteries of the brain. So, coordination, motor coordination, like patting your head with one hand whilst rubbing your tummy with the other. A few people can do it straight away. A few find it impossible, and the majority can do it, but with a bit of practice. So why is it so tricky? Let's take a look. Well, it all comes down to the way our brains are wired. The human brain is ridiculously complex. As you'll know, it's made of cells called neurons. 100 billion of them. But they're not isolated cells, no. As things are learnt, facts or movements, they build pathways to each other. And each pathway is like a physical, learnt, self-written instruction manual for the next time the brain tries to do the same thing. And it's thought there are more neural pathways in each brain than there are stars in the entire universe. So, rather a lot. Of course, one of the brain's many jobs is controlling our movements. And that's what we need to look at to answer our question, why is it that patting and rubbing at the same time is so tricky? And as regards the one I'll show you a bit later, apparently almost impossible. Let's find out. Supposing I decide to pat my head and rub my tummy. How does it go from I decide to actually happening? The body doing what I wants it to do. Now, nobody's entirely sure what I is. It might be the area at the front of the brain called the prefrontal cortex, or lots of areas of the brain working together, or indeed something outside material reality. We don't actually know. But certainly I exists. And it's I, ultimately, that makes the decision to pat head and rub tummy. But whatever I is, it can't actually move our hands. It just decides stuff. So how does I get us to move? And it's quite simple, and in a way, fairly obvious. I simply sends a message to the movement part of the brain, telling it what movement it wants the body to do. The main movement part of the brain is called the primary motor cortex. It's a good name. Motor, because it controls movement. primary because when it comes to movement, it's the boss. And cortex, which simply means an outer layer, because the brain's cortex is a layer of brain material that's wrapped round the rest of it. So after being told to by I, it's the primary motor cortex that instructs the muscles to move, patting our heads and rubbing our tummies in our example. But unfortunately, the primary motor cortex, the boss, is a bit dumb. For example, it's rubbish at planning how to do the actual movements. Luckily, it has two very clever advisors who stop us from looking like Mr. Bean. And once those advisors know what movements the primary motor cortex wants, they sit down and work out how to do them, which muscles need activating, and in particular the order in which to activate them. The order. Very important for walking, of course, putting one leg after another. Otherwise we'd hop from place to place. Those two advisors are called the premotor cortex and the supplementary motor area, and very sensibly are found right next to the boss. So now, thanks to these three working together, deciding and then planning, we can pat our heads and rub our tummies. But there's a problem. The movements controlled by these three areas can be very clumsy. And luckily, again, there are two other helpers that can sort that out. The cerebellum, which makes the movements smooth and accurate, and hidden deep in the brain, the basal ganglia, which is rather like a referee. When the messages from all the others come through, it takes a close look at them and decides which messages are good and lets them through, and which ones are rubbish and should be blocked. And that creates what's known as a neural pathway. Think of it as a physical set of instructions that the brain keeps in case I wants to do that same movement again without having to figure it out from scratch. In effect, forming pathways allows the brain to turn a conscious, thought-about action into a skill. The movements, typically, have been in effect hardwired into the brain, requiring no more thought, no more messing around to find the right movements, as with riding a bike or catching a ball. And that's the whole process of how we can pat our heads and rub our tummies. The boss, its advisors, its referees, and the memory, the pathway of how to do it. So after all that, how is it that our hand movements sometimes go wrong, like the first time we do the patting and rubbing coordination exercise? Well, there are two main reasons. First, the structure of the brain, and second, the movement, patting and rubbing with different hands, is unusual. It's not a familiar activity. Okay, first, the structure of the brain. We need to understand that our brains aren't just lumps of grey matter. They're actually split into two discrete halves, or hemispheres, as they're called. The right hemisphere and the left hemisphere. And, along with other things, each hemisphere controls movement. Each hemisphere has the boss, advisors, and referees that we've investigated. But rather strangely, the right hemisphere controls our left side, our left arms and legs, for example. And yes, the left hemisphere controls our right side. So when we're walking, it's the left hemisphere that tells the muscles of the right leg to move, and it's the right hemisphere that controls the left. Rather messy. And I guess that's why we sometimes call very young children toddlers, because they toddle rather than walk whilst they're getting the hang of putting one leg after another. Putting one leg after another. But if the two hemispheres are separate, how on earth do we get these two hemispheres to work together so that one leg does follow the other? Well, the hemispheres are separate, but they're actually connected by a bundle of nerve fibres called the corpus callosum, along which they send messages to each other, rather like a networking cable that connects two separate computers so they can communicate with each other. And that's how the left hand, as it were, knows what the right hand is doing. But of course, unlike walking, in our example, the hands are doing very different things. Patting and rubbing, not just moving in similar ways like walking. Obviously, patting with one hand or the other is easy, and it's the same for rubbing with either hand. These simple pathways are laid down very early in life. The memory of how to do it, the instructions, are built early into our brains. Indeed, the two hemispheres find doing similar things quite easy, like clapping. "I'm swinging my hand," says one hemisphere across the network, the corpus callosum, and its neighbouring hemisphere replies, "OK, I'll do the same." But when the hands are trying to do very different things, the chat goes something like this. One hemisphere says, "I'm patting now," and the other replies,
What? The boss told me to rub.
"Are you sure?"
Well, I think so. Oh, now I'm completely confused.
And we see the results of that confusion when our hands start misbehaving and waggling all over the place. The second main reason for our hand movements sometimes going wrong is that these movements are unusual, not something familiar that we regularly practice or encounter in daily life. The neural pathways, those learnt behaviours, don't yet exist as they do for other motions that have been done over and over again. But in most cases we can overcome these challenges and, with practice, our brains will adapt and build those necessary neural pathways. Hence we can learn to type on a keyboard, play a musical instrument or a computer game, even use a smartphone, though that one's still a bit of a mystery to an old codger like me. I think I come from a generation that, well, basically barely used its thumbs. OK, now that we know how all this coordination works, let's try to do the so-called impossible together. I'll slip on some white gloves so you can see more clearly. Turn a little bit to my side. OK, let's start. First, with one hand, describe a small orbit going round and round like this. Nice and easy. But now, with the other hand, describe a larger orbit around that smaller one, but going in the opposite direction, like this. I'll just keep this going so you can try and copy it and build up those neural pathways. How are you doing? Okay? Now I'm going to go faster on the outer one and faster on the inner one instead. And now reverse the process. Reverse the orbits and even go in the same direction. Did you prove that it's perfectly possible? Anyway, well done for trying. Let me know how you got on. And if you could just stop moving your hands for a moment, please could you use them to click the like and subscribe buttons. Much easier and much appreciated too. A bit of fun investigating the brain's amazing ability to coordinate the body's movements. And until the next investigation, many thanks for watching. I hope you enjoyed the challenge. Cheerio.
There are more things in heaven and earth than are dreamt of in our philosophy.